Hello and welcome to another video. This is going to be concerned with the chi-square. Chi-square is a t-distribution that is going to be suitable for categorical type of data. This is include, of course, nominal and ordinal. If you know, for example, if you know many examples in real life where we need to have an answer for yes or no, comparison between female and male, answers that based on a group of people like Democrat, Republics, or others. Those the type of thing that is chi-square is suitable for. And if we take a look at the situation where we're going to be throwing a die has six values on it. It's a cube, and it's going to have 1, 2, 3, 4, 5. Let's assume this experiment has been done by doesn't matter who is doing the throwing, but they claiming that the die that actually being thrown is going to be a fair one. So that's actually the hypothesis test. The hypothesis this die is fair. The alternative hypothesis is the die is not fair. Therefore, we're going to continue to test this null hypothesis based on the observed data. Also, we're going to be able to figure out what is the expected value and calculate the chi-square manually based on the alpha, or which means the confidence level of 99%. So alpha is going to be 0.01. So all this is going to be done very quickly because really, if I'm using Excel as my favorite calculator in this case, it's not going to take us too long to do it. So I'm going to be able to, first of all, agree with the fact that at alpha at 0.01 has a chi-square that is coming directly from the Minitab software. So I'm going to click on Minitab, and I'm going to go ahead and show you how to get the chi-square based on the alpha as 0.01. But before we do this, we need to understand that we have one variable in this case. The variable is the value of the observed value. Those are actually the label of the categories, which is 1, 2, 3, 4. And we have to figure out what is the degree of the freedom. Degree of the freedom is the number of the columns minus 1 multiplied by the number of the rows minus 1. I don't have a column here per se because this is one variable observation, so it has a special test for it in chi-square. But even we have 2 rows with the 6 rows with the 2 columns, 2 minus 1 for the column 1 and 6 minus 1 for the row is going to give me 1 by 5, which is going to determine the degree of the freedom of 5. So keep that in mind how we calculate the degree of the freedom. If I have 10 rows by 10 columns, the degree of the freedom is going to be 10 minus 1, which is 9, multiplied by 10 minus 9, which is another 9. 9 by 9 is 81. So you should be able to calculate the degree of the freedom based on the number of the rows in the column. And that's actually more than one variable for sure. So let's go, not to lose track of this. I wanted to go ahead and go to the graph, and we're going to go to the probability distribution. I'm going to use the same thing I use for Z distribution, for the Z score, for the T, for also the probability, proportion. And we're going to be able to see what is the test under those circumstances where we have the degree of the freedom of 5. Of course, normal is the default distribution, so I'm going to change it to chi-square, where you have to scroll up, click on chi-square. It's 5, the degree of the freedom. And let's go ahead and click OK. And one thing I missed here. Okay, I'm going to go and close it. It's almost 3:30 in the morning, but could still do it. So when we're going to go ahead and do the graph, going to do probability distribution, change, go to the view. It should be here. Come on. And we're going to go ahead and change it to chi-square 5. The shaded area where I missed, it always you have to choose the right tail for the chi-square. Don't choose any of the others. And based on the probability of 0.01, because that's what we agree alpha is going to be should be giving me something like 15 around these values before I recall that. Yes, it is 15.09. So the critical region is going to be 15.09. If we do actually successfully calculate the chi-square based on the formula that I'm going to show you in a second, that value must be greater than 15.09 in order to conclude that or reject the null hypothesis. Let's go ahead and do it. So this one actually, the formula to calculate the chi-square is going to be the observed value minus the expected value. So the first time, when we throw these, we counted the number of the ones, they were 22. Where did the expected value came from? Expected value is the total of all the throws, okay, divided by the probability of each one of those. They all have the same probability, which is 1 over 6. So if I divided let's go ahead and actually I did here earlier, I did, let's go ahead and see here, 42, I guess. No, not 42. We could do it any number, it doesn't matter, you know. Let's go ahead and do this. This is 200. This one has to be divisible by 6. I'm going to go ahead and find something divisible by 6, like, let's say here 10. That's going to give me 9. Nope, let's go ahead and make it 18, 22. Okay, that's where I got the 34 earlier. You know, the 34 is 204 divided by 6 because I have 6 option. 0.04 divided by 6. That is the expected value of each one of those. So let's go ahead and take that out, of course, and look very closely at the formula, which I could easily do that. You know, I could easily do that by actually taking this pen here and write it. And I could say here x squared, well, I'm sorry, not square, chi is square. It's going to be the addition of the observed value is going to be 22 minus 34. That's the expected value raised to the second power. And the whole thing is divided by, what is the expected value, 34. So then I will have to add this to the next one. And notice I'm going to go ahead and see the observed is 45 minus, that's how you should do it manually, minus 34. And that's raised to the second power, which is square, and the whole thing is divided by 34. And you keep adding those for the 6 of them. So instead of doing this, you know, I'm going to go ahead and erase this and go ahead and do it manually in Excel. So I'm going to go ahead and do this. Go back to this one here, and I'm going to be doing here that equal of observe is 22 minus 34. That's the first expected value. On all of them, the same expected value. Raised to the second power is caret sign divided by expected value, which is, let's go ahead and use this so I could really use the fill handler quickly. And here we go. We're going to go ahead and do this. And the same one for each one of those. This is 0 because, of course, and here we go. If you do the sum of all this, the sum of all this, and look here, we are going to actually get the 17.823, which is greater than 15.09, which is we're going to conclude this is actually a fair, not fair, because we said that that is not as fair. We're going to conclude that the die is not fair, which is to reject the null hypothesis. This is very good quickly, and to do this, you can do it manually, and of course we're going to do it in using the software as well. So we're going to go to the stat, and here you need to give your attention to see where it's not through the basic statistic, is basically done it through the table. Since we have one variable, we're going to go to the chi-square goodness of fit, and here we go. We're going to go ahead and say, or remember here, I named the variable, the first variable die, which is only the number, die number, and then the observed values for this, which is going to be a little bit different. I have to change this because I've been playing with it. So this is going to be 22, 45, 33, 48, and this is a change to 34. Okay, in order to keep everything straight. And here we go. We're going to go ahead and do that. Now I could run this without any confusing result. So let's go ahead and do, at least when we do the contribution of chi-square, and we have to get this one here similar to what we got in Excel. So we're going to go to the more time to the stat, go to the table. It's one variable, which is the number of the observed values for the die. And we're going to go ahead and say, all right, where this is coming from, first of all, let me go ahead and delete it so you can see it. Since I named my variable in that gray area under the columns number C1, I'm going to start with the observed counts, which I'm going to either, actually, let's click on it twice is the easiest way. Oh, it's the wrong place. So I need to make sure the cursor is clicking on the observed counts, and here we go. Then we have the category name, which is really optional. I'll put it there. It's equal proportion. That's exactly what I want. The result, I'm actually displayed this result for everything. And I'm going to go ahead and OK, which is very nice. It shows you basically the chart. You notice that all the expected values are the same. That difference is really in the observed value. So I'm going to get rid of the graph and I'm going to close it. I needed to know this is basically correct because that's what we obtained from the contribution to the chi-square for each die, which is going to be added up to exactly what we got it through Excel. This should be equal to this. And notice that 003 is less than 0.01. Therefore, we're going to reject the null hypothesis. Chi-square is bigger, so it falls in the rejection region and the rejection region, and the B value is going to be 0.003, which is less than 0.01. Also, that emphasizes the fact that is the null hypothesis going to be rejected. One more thing before we leave this topic very quickly. Let's assume that I have more than one variable. In this case, I have more than one variable. Assuming that I have, let's say, I'm going to make up very quickly the numbers. I have Republican here, okay? Okay, and we have Democrats, and we have others. They have no political preference. And there is 14 men in the Republican. This is the man, and this is actually the female. So we could go ahead and say 10 for the female. And we're going to go ahead and say Democrats. We have 40, let's say 50 Democrats, women, and male. And we have, let's say, 15 of the women, and just making up those. And we have 5 others, and we have a 3. So it doesn't matter. Actually, we're going to go ahead and run this test. So this is male for the first row, and this is female for the second row. And we're going to be able to go ahead and run this very quickly. That's based on a study that we've done. All right, so what we're going to do, first of all, to decide based on the number of the observation for the women and male, that the gender of the person is going to be independent of the political affiliation. So in the alternative hypothesis is going to be they are actually not independents. They are, they caused by each other. I mean, caused by the selection of a specific political party is caused by somebody's gender. Not caused, sorry. We don't know how much causation. Causation is a very big word. There is what do we call it? Evidence that there is link between the gender of the person and the political party they join. So let's go ahead and see how we're going to do this very quickly. You're more interested on how to do this. You don't have to highlight anything here. So we're going to go to the stat again. We're going to go to the table again. We're going to go now, instead of chi-square greatness of fit test, which one variable have more than one. So we're going to go to the chi-square test for association, which is really very powerful stuff. So now we have to make sure that we are summarize the data. And to summarize the data, we have those 3 of them. We're going to click on the Republican, Democrats, and the others 3 of them. Everyone two of them. And we're going to go to the, I don't think we need to look at any of those. Here we go. And I'm going to go ahead and click on the OK. Maybe I need to put the number of the rows, which is in this case is a 3. And uh-oh, it didn't want me to do this here. So let's go ahead and do this. Okay, that's why I thought is maybe. All right, let's take a look at this. The B value is 0.575. This is a huge value. The null hypothesis that the gender is independent of the political party. Obviously, we reject that null hypothesis. So there is dependency between the political party and the gender. And therefore, because of the data, I mean, I made up the data quickly. If you do observe the data in the real world, you might completely get different results. I don't believe what I just said. I'm just running the show and learning the software based on makeup data just to get the practical aspect and how to go about going to the stat, going to the tables, going to the chi-square for association when I do have more than one variable. Okay, I have here males and females. In addition to this, I have 3 different association with each of these 2 values, male and female. Thank you for watching. I hope you enjoyed this. I hope you learned something, and I really appreciate you taking your time to watch this. Taking me now, it's 3:30, so please take advantage of this videos. Bye-bye.